what is happening is we've realized when they use antibiotics in foods and all of that, that has been fighting against our, it's creating a lot of resistant organisms, has been having a side effect in our health and things like that. Radiation, what it does, radiation affects DNA and even proteins. We have two forms of radiation. We have ionizing radiation and non-ionizing. Ionizing radiation, these are higher, shorter wavelengths, so it's much more powerful. The waves are much closer. What they do is they can break DNA into fragments. So fragment all the DNAs. And their power is so much that they can actually go through a barrier. X-rays, gamma rays, these are forms of ionizing radiation. Non-ionizing are much weaker. So first of all, they won't penetrate any barriers. And second, what they do is actually they kind of break the hydrogen bonds. They don't completely affect the sugar phosphate. They create nicks in the hydrogen bonds and all of that. So it is possible for the DNA to recover, but that's kind of an effect they have. Examples. Ionizing radiation. This has been used in Europe for much longer than us, and now we're starting to use their technique because Europe has stopped using or limited the number of antibiotics used in the food and things like that, chemicals, way before us. We are just starting to pay attention to that. So they were healthier with regards to the food. So what they do, electron beams are good for a thin layer. X-rays go deep, but the power is lower. They actually use gamma rays. So kind of what Hulk got to become Hulk. But gamma rays, what they do is they package the food, like even meat, milk, and all of that, fruits, they can package it and then pass it through gamma rays, slowly pass it through, and that gets rid of the DNAs, fragments every DNA. And it won't affect the nutrients because it really breaks the DNA. So it doesn't damage really the protein, other nutrients that it has. It's pretty good. Then I have typically the questions of, is it getting radioactive? When you get an X-ray, are you becoming radioactive? No, right? The second the X-ray stops, you go back to normal. Just because you got an X-ray, when you stand next to someone, they don't get an X-ray. So the beam has to go through you. Radioactive is radioactive material. They're constantly breaking down and producing radiation. So that's totally different. All right, so it's very safe, very good. Non-ionizing, this is like the UV lights. So in surgical rooms, dentists' offices, when they've cleaned everything, some flow hoods, when you cleaned it, then overnight or when that room is not being used, they have ultraviolet lights. They turn it on, close the room when they want to go in. What it does, it cleans the surface. So if I shine ultraviolet on the surface of this table, it will just clean the surface, doesn't go underneath it. The light has to pass underneath it in order to make sure. So that's the difference between non-ionizing and ionizing. All right. Now we're going to talk about chemicals and chemical methods. Again, they can affect the same things, DNA, protein. When we go through the chemicals for each of them, what I want you to know, this is the list of types of chemicals that we're going to look at. For each of them, I want you to know one very popular form that we all use. Like for example, for phenols, Lysol is a phenolic. It's from the same family of phenols, right? And we use it all the time. Just know an example of it. What does it affect? Typically, I have it up there. Protein, PM, remember, is my shorthand for plasma membrane. All right, phenols or phenolics. Remember, this is carbolic acid that Lister. blister the surgeon started using, and it's the first antiseptic that he started using for cleaning the patients and the tools and things like that. So it was the first that they knew, and they created the variety of different forms of it. It is about intermediate to very low level. It's not that great, but it's good. Lysol, Lysol, we use it at home. It's okay. It will affect proteins, so it plays with the charge of proteins, and it can denature proteins. And because of that, it can denature the proteins of the plasma membrane. So it affects the transport also. Examples of that are Lysol. We use it in a lot of areas, so phenols. But it's not as popular as before. It's just used for general cleaning nowadays. You can actually see different forms of it in toothpaste, in makeup. Then alcohols. Alcohols, I don't even have to tell you guys to remember it. So isopropanol, that's rubbing alcohol. Ethanol, those are the different kinds. Alcohol is, first of all, a solvent for lipids, so it affects the plasma membrane by interfering with the phospholipids, but it also can affect proteins too, kind of with the different charges of the protein. Alcohol is very good. It's intermediate to higher level. Isopropanol, the chemistry of it makes it work even better than ethanol. And even sometimes if you make it, like, first of all, there is no 100% alcohol. You always just find 90% out there, all right? 70% sometimes for medical purposes works a little bit better. Why? Because the alcohol affects the plasma membrane, right? So increase the amount of water in the environment by adding it to the alcohol. It makes the cell burst open faster. The other good thing about alcohol is it evaporates. It has a very low evaporation point. So when you're using it for doing procedures and all of that, it won't interfere with your procedure. It will clean the area. When you're giving an injection, it's not going to interfere with the medicine or whatever, or if you're cutting, not going to get inside. So it's good. But it's bad because of that too. If an area is hot, that alcohol can evaporate fast, and when it's gone, then the area can get contaminated again. All right? Next, halogens. These are a specific column in the periodic table. Chlorine, iodine, bromine. These are all halogens. So we can actually use it. Betadine has iodine in it. Chlorine that we use has chlorine in it. All right? Chlorides in it. So they are very good at oxidation. So when they are good at oxidation, they interfere with proteins and your DNA. They can denature your proteins very fast because they oxidize them. So because of that oxidizing effect, they're good. So bleach has chlorine in it. Betadine has iodine in it. There is bromine disinfectants that they can use in hot tubs. Again, these are all halogens. Perfect example, betadine, chlorine. They will affect the proteins, and they are oxidizing. Then we have oxidizing agents. Hydrogen peroxide is the best example in this. Ozone is another one. These are very reactive with electrons, and they're very good at oxidizing. So they can affect a large group of molecules in the cell. They can actually be intermediate level, pretty good. Hydrogen peroxide is the one that we typically use. But again, we've kind of talked about it. Warning, it's good for an intact skin, or for sometimes dentists when they're going through a procedure, they go, hey, before that, gargle this thing and spit it out. So for an intact area is good. Inside of our cells, remember, we are aerobic cellular respirators. So sometimes where oxygen takes our electrons and makes water, it makes a mistake and makes hydrogen peroxide, H2O2. We have the enzyme catalase that says no problem. I'll break it down to water and oxygen. Hydrogen peroxide for your cuts is not a good thing. That's why when you're putting it on it, it's good for cleaning everything around it, but when you put it on the cut, you see it bubbling and everybody's like, oh, it's working. No, it's not. It's turning into water and oxygen. So it's good for getting debris and everything out because it doesn't burn, it doesn't add to the paint. But after that, if you really are worried about the bacteria, you have to either use antimicrobial ointments or alcohol or water, soap, things like that to kill the bacteria. For deep, deep wounds, it's actually not bad, again, for cleaning and all of that. After you've used alcohol or some other disinfectant, pouring it in there allows for rapid production of a large amount of oxygen, which can go into the dead tissue, which are not getting blood, therefore not getting oxygen. If you close that wound and it has something anaerobic bacteria, like Clostridium perfringens, which causes gangrene, then that thing is like in heaven. You have an anaerobic deep wound and tons of nutrients, dead tissues. So sometimes they pour it to make sure that it gets oxygenated, then they close it. So, but keep that in mind. Surfactants. These have detergents, soap, quats are associated with it. What they are, they have, like, detergent is way better than soap. So if you're really worried about something being dirty, use your soap dish. Dish soap. So the dish soap, that is a very strong detergent. It has positive and negative parts, and it goes and interacts with the cell membranes and a lot of negative and positive charges. We actually, for lysing cells, we use an extreme powerful detergent called SDS, and that actually ruptures cells. It's so strong. So detergent is much better. Funny enough, they've picked up on that, and they're using that for Dawn. They say if somebody's like, this gets rid of 99% of the germ, so they're using that for Dawn nowadays too. That, hey, it's even better than your soap. So not only you can use it for this, you can use it for that. Soap is, again, same thing. They play with your molecules that have a negative and positive charge and disrupt their function. Soap, detergent. Quats is actually what we use in our lab for, cleaning the desktops. Some first aid kits you buy, they have alcohol swab, and then they have benzyl alkonium chloride, or they call it Zephyrin. That is also a part of a surfactant. So it's good, it usually doesn't burn like alcohol. Heavy metals. In the old days, they would put like water in a copper pot. That copper interacted with some of the microbes inside and killed them. Copper, for example, we use it for pools. We use it for some fish tanks. The copper stops the growth of algae. So it interferes with their chlorophylls and doesn't let algae grow. So it can interfere with some material. Thimerosal that we use for preserving vaccines does the same thing. It's actually metal. One of the other ways that we still use it, silver nitrate. They use it for wounds. They use it for babies when they're born. They actually put a drop of 1% silver nitrate in their eyes. So the bacteria that causes gonorrhea, if the mother has that infection, the baby comes, if the bacteria gets into their eyes, it grows and it scratches the cornea, so they become blind. 1% silver nitrate gets rid of that. So bacteria most often, heavy metals most often affect the 3D shape of the proteins. Silver nitrate, thimerosal, these are all examples of it. This is why some people actually who have an issue with metabolizing heavy metals in their diets and in their body cannot get vaccines because it makes them sick. Eventually their body gets rid of it, but they cannot metabolize heavy metals. So it makes them feel very sick. Then aldehydes. Guess what they are? Formaldehydes. Formaldehyde, although we don't use formaldehyde, we use an altered form of it. It's called formalin because they realized formaldehyde was highly carcinogenic. That's after a lot of morticians were dying from cancers. So this is the embalming solution that they use. Formaldehyde, again, interacts with proteins and DNA. It is so good that the long term is actually sterilizing, and short term it could be disinfectant. That's why you can actually have a dead body for a while showing when they have embalmed them, because it stops the process of. All right, and then last one, gaseous agents. These are examples of ethylene oxide, propylene oxide. These are high levels. They are extreme oxidizing. They denature proteins, DNA, cross-link all functional groups. So it's not just DNA or proteins. They can interact with a lot of functional groups. But we don't always use them. They are used in special, it has to be used in a special protocol, following a special protocol in a special environment, because they are extremely explosive, extremely poisonous, possibly carcinogenic. Because, why we say possibly? Because when most people who've been exposed to this, they die from it. But if they live, we think they're gonna get other issues. So this, sometimes they use it in hospitals, or like when they create those dialysis tubings and all of that, the IV tubings, these have to be very sterile. But they're made up of plastic, so they can't add temperature to it. Some chemicals interact with it. They actually use these gases, they put them there, and then when they neutralize the gas, that thing is sterilized and they package it right there, and they use it in the environment. But it's not used everywhere. And then antimicrobial drugs, I'll talk about it in chapter 10. Okay, so for all of these things that we've talked about, there are three very important things, regardless of money and all of that, which is, I'm going to talk about it in the next slide. Even if you are the richest company and the richest doctor's office and money doesn't matter, you have the best storage environment that you can store even the explosive ethylene oxide gas and all of that. You have a room that you can use the gas and all of that. But what you have to look at are these three steps. First off, the nature of the site that needs to be treated. Is it this table, or is it my skin? Or is it inside of me, on my body, all right? You can't treat a living being the same as an inanimate object, right? You can't autoclave me, but you can autoclave a scalpel, right? So, is it living or not? Second, degree of susceptibility. Am I worried about an enveloped virus on my skin? That's the most susceptible thing on the planet. Just warm water and soap, a little bit of alcohol is more than enough to get rid of it. You don't have to bleach me, right? Is it just that, or is it TB, Mycobacterium tuberculosis? For that one, it's very resistant. You need something much more powerful. So degree of susceptibility. Finally, environmental conditions. If it's a hot environment, that alcohol is going to evaporate too fast. So probably alcohol is not a good thing. If it's, let's say, if it is like a even the surface of your surgical room or emergency room. A patient came through, they were bleeding through, you have gauzes and all these things, and the person wants to clean the room. Hydrogen peroxide won't be a good thing. Why? Because when they pour it, the blood there would have catalase and will denature it. So you gotta see what you're using. Because of the environment, is it going to get denatured? Is it a combination of living tissues, inanimate? So you have to take these three into consideration. So that's the most important part. But then obviously you got to look about it and say, okay, am I using this at home? What am I worried about? I'm not going to go and use a high-level ethylene oxide in my house. But low level is good enough. Can I store these materials somewhere where it won't explode, and then that defies the whole purpose? So money, what's my budget? Those are the other things that we look at. Does it harm the beings that are around this? So if I breathe this in, can I die from it? Then methods for evaluating them. So all these new disinfectants and all of the products, every time they create something new, mostly even with chemicals, when they create something new, they have to evaluate it. And in the old days, they used to use phenol coefficient. So they will compare it to a phenol and say, okay, does it work better or worse? But nowadays, they don't even use that. What they do most of the time is this. In this industry, they use dilution tests. So they come and they have a reagent. They've created a new chemical. So they create dilutions of it, a series of dilutions. Then usually they take rods, steel rods, that have, let's say they want to check it against mycobacterium and see this new chemical product that we produce, is it good for getting rid of TB? Can we sell it for that? So they use steel rods of mycobacterium, and they've created dilutions. They put these steel rods in there, and let's say they store it for 10 minutes or so.